Hi, hearty welcome to you. We are going through properties of triangles, and in the last session we have gone through law of sines, where we have proven that A by sine of A equal to B by sine of B equal to C by sine of C equal to 2R. And the notation we'll be following is all angles are capitals and all the measurement of length or the sides are lowercase letters, and the angles and sides are opposite to each other. Once we are clear with that, let's go ahead with the law of cosines. To prove law of cosines, we have couple of alternate methods. We'll go through both of them. First, let's look at this method. Now let us say that there is a triangle ABC with sides as A, B, C respectively. Let us take B as origin 0, 0. If I know B equal to 0, 0, then automatically I know the coordinates of C are nothing but A, 0, because it's only moving in the x direction. Y direction there is no movement, no difference. So it's A, 0. Now also you can see that the coordinates of A will be nothing but, if this length is C, you want to find out the coordinates of A. That's nothing but equal to, if you take this angle as angle B, and you see from here, you know that x coordinate is nothing but this distance. That's nothing but equal to C into cos B. So can I say the coordinates of this are small c cos B, comma. Similarly, what is the vertical distance from the x-axis, or nothing but the y coordinate? Y coordinate is c, comma c sin B. I hope you are okay with that. What we have seen, we have started with 0, 0 horizon as coordinates of B. Then coordinates of C are nothing but A, 0, because you have to move in forward direction, positive direction of x-axis by A. And we know that coordinates of A are nothing but with respect to C, C cos B, C sin B, because the angle here is B and the hypotenuse is C. So you will have your remaining two sides of the right angle triangle, C cos B and C sin B. So the coordinates of A are C cos B, C sin B. But we know that by the triangle this distance is nothing but equal to B. So if I equate that, let's equate that and see what happens now. B, if I square it, B square, or should I say B is nothing but distance between AC, distance between A and C, that's nothing but equal to, what is the distance between them? C cos B minus A, C cos B minus A whole square plus C sin B whole square. This is the distance of B, because we know that the distance between 2 points is x2 minus x1 whole square plus y2 minus y1 whole square. Now if I square on both sides, I will have B square equal to C cos B minus A whole square plus C sin B whole square. Now let's expand this. There's nothing much. We will expand this and see what happens. B square equal to C square cos square B, and also from here I will have C square sin square B, and A minus B whole square, this is A square, B square is A square, minus 2AB, that is nothing but minus 2AC cos B. Now you can see we are having we can take C square common. If C square into cos square B plus sin square B is 1 always, cos square theta plus sin square theta is 1, we know that. So this is nothing but C square plus A square minus 2AC into cos of B. So you can see that b square equal to c square plus a square minus 2ca cos b. Now let us say that it's a right angle triangle at b. That means angle b is 90 degrees. Then you can see that this whole term becomes 0 because cos 90 is 0. And you can see that b square equal to c square plus a square, which is nothing but the hypotenuse square equal to sum of the remaining two sides squares. Okay, right. Similarly, if you take instead of a, you take b as the base or c as the base, you can prove the remaining ones also. You can prove c. If you want b, your b will be there only with the angle. Remaining all will be with the other side. It is c square plus a square minus 2ca cos b. Similarly, if you want c square, let me write it. If you want c square, you should start in the same pattern. B will become c, so c will become a square plus b square minus 2ab, and this is small c. You will have cos of capital C. Similarly, you can write for a square also. A square equal to, that is small a square equal to b square plus c square minus 2bc into cos of capital A. That's the law of cosines, which is useful whenever you know two sides of a triangle and included angle. Suppose you know CA and included angle B, you can find out B. Or you know all the three sides, you can substitute in that and you can find out cos A, cos B, cos C. So, it's useful whenever you know two sides of a triangle and the included angle between them. That means you know AB and you know angle C, or you know BC and you know angle A, or you know CA and angle B. That's when this will be useful. Okay. Now we can solve this in another way also. Let us do that, where we will not go through any, where we will not use any diagram. Directly we will take it from whatever we have proven. So we will start with, let us try to prove now. We have proven for b square, let us prove with a square. We have to prove a square equal to b square plus c square minus 2bc cos A. Let's prove that. Okay, I'll start from here. We have to prove a square equal to b square plus c square minus 2bc into cos of angle A. This is what I have to prove. I know that A equal to 2r sin A whole square. So I am starting with a LHS, that is 2r sin of angle A whole square. That is nothing but 4r square sin square A, 4r square sin square A. Okay. Now see here, we are starting with A, but we see the answer in terms of B's and C's. That means I should convert this back into B and C. For that I will leverage this property that A plus B plus C is equal to 180. I want to convert A into B's and C's because my answer is in B's. I know that this B is nothing but equal to 2r into sine of capital B, and this C is equal to 2r into sine of capital C. So I should convert this A into B's and C's so that I can somehow arrive there. This is nothing but 180 minus of B plus C. And you know that sine of A is nothing but equal to sine of B plus C. Why? Because sine is positive in first and second quadrant. So sine of 180 minus theta is sine theta. Now what this becomes? This becomes 4r square sine of b plus c whole square. Can I say that? That's nothing but equal to sine square b plus c. Now sine b plus c whole square. So what I can do now is I can expand the sine of b plus c. It becomes 4r square sine b cos c plus cos b sine c whole square. Now we need answer only in terms of I should have everything in terms of signs as much as possible, because what I have to prove will have 4r square sine square b, 4r square sine square c. You see here, instead of b, I am writing 2r into sine of capital B. So I should have all as much as possible in sines only. So I will do that. What I will do, I will write it as 4r square into sin b cos c whole square, that is sin square b cos square c, I will write it as 1 minus sin square c, plus I will have cos square b sin square c, that I will write it as 1 minus, that I will write it as, I will do that step. If I am confusing you, I will write that step somewhere here. What I will do now, I will write it as 1 minus sin square b, that is cos square b, into sin square c, plus 2 sin b sin c cos b cos c. This is nothing but equal to 4r square into sin square b plus sin square c sin square b plus sin square b into 1 plus sin square c. Then I have minus sin square b sin square c, and also here I have again one more minus sin square b sin square c. I will write it as minus 2 sin square b sin square c plus 2 sin b sin c cos b cos c. Now we'll take one more step so that we will get there. That step will be, okay, should I take it here where we have space? No, we don't have space. That's okay. Let me try to adjust here. Now what is that we are having? 4r square sin square b sin square c. You can see here 2 sin b sin c I can take common in these two. If I take 2 sin b sin c common, this becomes cos b cos c minus of sin b sin c. That's nothing but cos of b plus c. Can you see that? What it will become now? If I take common, it will be, I'll write in small letters. Okay, let me write it here. After this, I am going here. Okay, pardon me for that. Okay, now what is this? 4r square into sin square b plus sin square c plus, if you remember, I told you that I can take 2 sin b sin c common. If I take 2 sin b sin c common, I will have cos b cos c minus sin b sin c, which is nothing but equal to cos of b plus c. I will write it. I will have 2 sin b sin c into cos b cos c minus of sin b sin c. This is what you will have. 4r square into sin square b plus sin square c plus 2 sin b sin c into cos b cos c minus, this is nothing but cos a cos b minus sin a sin b. So this becomes 4r square into sin square b plus sin square c plus 2 sin b sin c 2 sin b sin c into cos of b plus c. Are you okay with that? Because cos b cos c minus sin b sin c is nothing but cos of b plus c. Now what you can do, 4r square sine square b is nothing but, you know that 2r sine b is equal to 2r sine b equal to b. So this is nothing but equal to b square. 4r square sine square b is b square. 4r square sine square c is c square. And 8r square sine b sine c, I can write it as 2r sine b, 2r sine c. That means it will become 2bc, and cos of b plus c is nothing but cos of minus cos of a. So it will become minus 2bc cos of a. If you think I have missed one step, I'll see where I can write it. If you think I have missed after this one step, I will write it down here. See, what we want to do is 4r square into sine square b plus sine square c plus 2 sine b sine c into cos of b plus c is there, that I can write it as minus of cos of a. I hope you are okay with that. This is nothing but 4r square into sine square b plus sine square c minus 2 sine b sine c cos of a. Now what I will do? A equal to 2r sine a, b equal to 2r sine b. If I substitute that, it will become a square, 4r square, sorry, b square, because 4r square sine square b. So should I say c equal to 2r sine c, because that is what we are using now. We are using what we are using, that only will write. We are using c equal to 2r sine c. This becomes b square plus c square, b square, 4r square sine square b is b square plus c square minus 8r square sine b sine c. I can write it as 2r into 2r into 2. So it becomes minus 2b c cos of a. I hope you are okay with that. If you think there also we are missing one step, what I can do is I can put that step directly so that you can check it. What we can do now, I can say 4r square sine square b plus 4r square sine square c minus 2 into 2r sine b into 2r sine c into cos of a. After this, you will have the last step. Okay? If you think we have missed a couple of steps there, I have tried to give them here. I hope it's not that clumsy as it looks, and you are okay with that. So we have seen two methods how to prove this law of cosines. One is we have taken horizon as 0, 0, coordinates of b, then we know the coordinates of c. We found the coordinates of a in terms of c, then we have equated the distance AC equal to b by using distance between 2 points, and by that we have got it. Another way of looking at it is we know a equal to 2r sine. Suppose we want to prove for a square, we know a equal to 2r sine a. We have taken from there, that is 4r square sine square a. We have taken it, now converted sine square a into sine b plus c whole square. Then simplify it and keep it in completely only in sines, and again translate it back to lengths, sides, by using formula a equal to 2r sine a, b equal to 2r sine b, and c equal to 2r sine c. You will have a square equal to b square plus c square minus 2bc cos a. Similarly, you can do one thing. Similarly, you can try for b square. Take b equal to 2r sin b. B square will be 4r square sin b plus c whole square. So, you will have 4r square sin square b. Sin square b you can write it as sin square of a plus c. Then you can expand sin a plus c whole square and you can convert this whole thing into sin and you can take care of that. We'll see in the next video where we will do law of sines is over, law of cosines is over. So we will do tangent related, what we call it as law of tangents. After that we will look at projection rules, which is very interesting. Okay, catch you in the next video. Thanks for visiting. Bye for now.